Good afternoon, students. Good afternoon. Checking that you can hear me, I can see the screen.
Yes, sir, I can hear you.
Alright, so I have a problem. Because I want to do some new stuff today. Right? But we have like less than half of the class here logged in. So what do I do? And this is important stuff. So I'm in a dilemma right now. Do I go ahead with the original plan? Or do I just, do something different? Because I really don't want to be doing stuff and people missing out. I don't know why a person not able to join online, but this is like less than half of the class that is here logged in now. There's 18 persons logged in. The session is being recorded. So what I'll do, I sort of curtail what I plan to do today. And just do something that should be relatively simple. I wanted us to progress with the trigonometry of non-right angle triangles, but I think I'll just come back and do the application topic for non-right angle triangles instead of going to sine rule and cosine rule, and we do that in the face-to-face again Wednesday and Thursday. So what I'll do today is something that is easier to explain when we get back to face-to-face class for those who are absent. All right, so that's what I'm decided to do. So that's what you see on the screen. One of the things you're seeing on the screen is this. So when we're doing trigonometry, we're gonna be encountering a lot of situations with parallel line. There's some angles that I want us to identify your expected angles and use them to do your calculation. I'm not going to show you every angle. There are some angles to be able to deduce, and once a part situation, and there are certain angles that you expect to be. So this first, two lines are crossed by a straight line. That straight line is called a transversal. A straight line that crosses two parallel lines is called a push there again. Hope this doesn't keep happening. Just lost the internet. So let me see. Everybody back with me? Just lost the internet a moment ago. Let me use the hotspot option. Hello?
Wait,
Somebody has to
what did you
answer.
say?
Can you see the screen?
Yes, sir.
Yes, sir.
All right, cool. Right, so I was saying when a pair of parallel lines or any number of parallel lines is crossed by another line, so like you have a pair of parallel lines like this, and those two lines are crossed by some other line like this. So these two lines parallel with the arrows on them. This line that crosses those two parallel lines, this line is called a transversal line. Transversal line. Transversal line is a line that crosses at least a pair of parallel lines. And that line will make angles with those two lines that are equal, or they make angles in the same way. So for example, this angle right here that it makes with the transversal is same as this angle right here that the parallel line makes with the transversal. And then this angle over here is the same as this angle over here. And those angles are called corresponding angles. Alright, they are called corresponding angles. But in addition to those angles that are corresponding, we have some other angles that are formed, which we call Z angles. And we also have what we call co-interior angles. So if you come down one of the parallel lines like this, go along the transversal, and then continue down the other end of the parallel lines, we are forming what we call Z angles or alternate angles. So this angle inside here and this angle over here seems like angles in this Z, in this blue Z. They are called alternate angles, or simple term to call them Z angles, because they seem like angles in a Z, right? They seem to be like angles in a Z in a sense. So we refer to them all as Z angles, but the mathematics, the mathematical name for them is alternate angles. Then we can also form what we call co-interior angles. So examples of co-interior angles are this now. Let me do this one for you. So co-interior angles, if I use the blue again, it's like you come down one of the parallel lines, go along the transversal line, then you continue up now the same end of the parallel line. These two angles in here, they are called co-interior angles. I call them U angles because they seem to be like angles in a U. Right? So like this and this parallel, they appear as if they are angles inside the U here and here. So I tend to call them U angles because this looks like a U now, right? Looks like we have a U. And so I call those U angles. Now, what these two angles do is that they add up to 180 degrees. These two angles, they add up to 180 degrees, these two. All right, and they are called supplementary angles. All right, so they are co-interior angles. That's a scientific name for them. I call them U angles because they seem like angles in the base of a U. And they are supplementary. Supplementary means that they add up to 180 degrees. And those are two kinds of angles that we need to be able to identify. All right, and there's some other things happening there as well. But let's go back to the slide. All right, so that's a transversal line. Straight line crossing two lines is called a transversal line. All right, so the Z angles, and they also used to call them internal angles. Instead of internal angles here, I think the better name for it is co-interior. Co-interior angles, which I just call U angles. All right. So let's talk about the Z angles first, what I just showed you a while ago. So parallel lines, Z angles and parallel lines are equal. So let's say the red line here in this diagram is a transversal line. And we have that first line. I'm going to make a parallel line to it. But first I'm going to make an angle alpha to that line. Now if I were to copy that line, the blue line, copy a parallel line onto it and shift it over, you see that angle is the same. Let's cut it again. That angle is the same. All right. Then now what we need to understand and know as well is that we have another angle that we should know, a property of trigonometry too. We should know. And our angle is on the opposite side of an X with two lines cross. these two angles are vertically opposite and they are equal. Every time you have an x, angles on the opposite side of the x are equal. They are called vertically opposite angles. And so since this angle up here says alpha, it means that this angle under here is also alpha, because they are vertically opposite angles. They are opposite angles on the x that we are forming right here. These are some properties that we're gonna have to just learn and know and use. All right. So I'm using that angle there as alpha because they are vertically opposite. And then if I take off this original one from the diagram, take this one off the diagram, then you are left with these two, alpha and alpha. And those now are what we call alternate angles. See, they seem to be like angles in the C. And they are equal. And that's the first property I want us to appreciate when you have parallel lines crossed by a transversal line. All right, those two angles are equal. Then now we want to talk about now the co-interior angles. As I said, I'm not calling them internal angles anymore. I'm calling them co-interior angles. I used to call them internal angles in the past, but find that they tend to be using the term co-interior more in textbooks now. So that's why when I was in school, I used to call them internal angles. All right. So we're going to use the same situation to create the concept of the co-interior angles. Now, co-interior angles of parallel lines are supplementary, and the word supplementary means that they add 280 degrees. So the co-interior angles are supplementary. Let me take this off. It's hiding some of the information there. So as we said, these are co-interior. All right, and they add up to 180 degrees. I just showed you a while ago. So if I copy the situation that we accept already, what you're gonna find is that this is a straight line. Focus right here now. A straight line here. From here it is a straight line across that point. An angle and a straight line across a point add up to 180 degrees. Angle and a straight line add up to 180 degrees. So if we call this piece of the angle here beta, it means that the alpha plus the beta is 180 degrees because they complete the angle on that straight line across that point. All right, so that's what I'm going to be using here. Call that beta. So because the total angle of straight line is 180, then the alpha plus beta is 180. And so now if I remove this angle from the diagram, this one, take that off the diagram. Why did I press that one? Take this one off the diagram. I'll be left with these two. Alright, that's what we're gonna do. Take that one off the diagram. I'm left with those two. The alpha plus the beta equation down here is still valid. And those two angles now are angles inside what looks like a U. And they are co-interior angles. So this angle and this angle, they add to 180 degrees. And remember now, you cannot have Z angles unless you have parallel lines. And you cannot have co-interior angles that add up to 180 degrees unless you have parallel lines. You must have parallel lines that are joined together by what we call a transversal line for it to be even considering about Z angles and co-interior angles. You must have parallel lines first. All right, so let us be mindful of that. So that's what I wanted to show you. These are what we're going to have to use on questions. You have to be able to identify Z angles. You have to be able to identify co-interior angles. All right, we're not going to do any question with it yet. I'm going to introduce now elevation, angle of elevation, and angle of depression. All right, And I'm not going to do anything more than that because this is something that can be explained in the classroom. That's what I'm going to put on the next slide right here. Angle of elevation and angle of depression. You can see the subheading there on the screen. Now, what are angles of elevation and depression? Angles of elevation and depression are formed when you have to elevate your line of sight to look upwards, or you have to depress, mean push down your line of sight to look downwards. So an angle of elevation is the angle above the horizontal. The angle above the horizontal that you have to elevate the line of sight to look upwards, and it is the angle through which you have to depress or push down your line of sight below the horizontal when looking downwards. And then there are certain properties that we're going to pick up as we go. So in simple terms, that's what the angle of elevation and depression is. All right. Some other textbooks, some depending on which textbook you read, the definition might vary a little bit, but I want to keep it simple and just simply say, it's like you're standing and you're looking horizontally first, you're looking straight ahead. And then you have to look up at the top of a building, for example. You're going to have to lift your head to a certain angle. So your line of sight now is elevated above the horizontal. The angle through which you have to elevate your line of sight above the horizontal in order to, for example, look at the top of a building is the angle of elevation of the top of the building from you, right? And these angles of elevation and angle of depression, both of them are measured from the horizontal. So the horizontal is a reference line for the angle of elevation and the angle of depression, and we can put this into a real life situation. All right, so let's look at the screen now, just given a real life situation on the screen. So like you have two gentlemen looking at each other. One is on the ground and one is at the top of this tower or this vertical object. And let's say they are communicating, they are talking to each other and they are looking at each other. So because the one on the ground is looking upwards, he will have to elevate his line of sight above the horizontal, and the one at the top is looking down, and so the one at the top, he would have to depress his line of sight to look down at the man on the ground that he's talking to. I'm going to put some lines on the diagram to represent what we're talking about. So that is the line of sight that they are looking at each other. So they share the same line of sight right now. They're looking at each other, right? So that is the horizontal eye level for the man on the ground. So if he was not looking up, it's almost like he would be looking horizontally. All right, and he has elevated his line of sight to that angle there that I've just marked alpha. Look at it again. He has elevated his line of sight to that angle that I'm marking alpha. So the angle of elevation of the man at the top of the tower from the man on the ground is alpha. That's the angle of elevation of the man at the top from the man on the ground. The angle of elevation is alpha. Then now, in terms of distance, you will have to elevate the line of sight to this distance that I'm pointing up on the diagram now. Right? That's what we call it the elevated distance. So the line of sight, look up at the man, would have been elevated to that distance there. And we are basically forming a right angle triangle because the angle between that vertical line and the horizontal line of sight is 90 degrees. And this is why angle of elevation and angle of depression is the topic that CSEC uses to apply your knowledge about right angle triangle, or to show how trigonometry of right angle triangles can be used in a real life situation. This is an example of the real life situation that is set questions on, right? So the majority of the time, or 99% of the time, when you see an elevation depression question on CSEC, it's a question that you'll be applying right angle trigonometry to. So you'll be applying so-called tower and Pythagoras' theorem because you're forming right angle triangles, because you then have a vertical line and a horizontal line involved in the whole setup. and those two lines will be at 90 degrees apart. All right. Now the man at the top, he also has a horizontal line of sight at the top, that red horizontal line eye level. And he now, in order to look down, you have to depress his line of sight to that angle, which I'm marking as beta. All right, so that is it. He has to depress his line of sight to beta, and that would be his angle of depression. He will also have to depress his eye level or to a certain distance, and that distance is over there. So again, at the top, we are forming a right angle triangle, which basically is in those red line along with the green line. And at the bottom, we have another right angle triangle, the blue lines along with the green line. All right. And then there are certain properties that we must appreciate. Now, first property we must appreciate is that these two lines are horizontal, and so they are parallel lines. And so the line of sight is like a transversal line. And so we have formed a Z. So you see I'm showing a Z on the screen. And so these two angles, the beta up here and the alpha down here, are alternate angles. They are Z angles. And so they are equal. And so we can conclude that the angle of elevation looking up is equal to the angle of elevation looking down. So if you know the angle of depression looking down, it will be equal to the angle of elevation looking up from the other end. And if you know the angle of elevation looking up from one end, that's from here, it will be equal to the angle of depression looking down up at that end. The angle of elevation and the angle of depression on the same line of sight will be equal because both of them are measured from the horizontal, and the horizontal is parallel at the top as it is at the bottom. All right, so that's one of the properties we want to pick up from now. All right, so I've simplified this diagram now over here by removing the man and all of that, put it over here. All right, so we have the alpha there still, we have the beta, and we have formed that right angle triangle. We're focusing on the one at the bottom, the blue with the green. All right, so in that triangle is a right angle triangle, so so-called tower is valid. Pythagoras' theorem is also valid. Right, we don't need sine rule and cosine rule once triangle is a right angle triangle that we're working in. All right, so I just told you that distance, we're calling that distance d. So these are some distances that you might know from information. So one man might be standing a certain distance away from the tower, and you might know the height of the tower because you might know the overall height and the height of the man out here, and subtract them to get this height up here. In the case, you know some distances in this situation, right? They give you some information about some distances, so you can do your trigonometry. All right. So that's about the things we can know. That alpha equals the beta. Just said that because they are Z angles. And then now we can work in this triangle, this right angle triangle, and this over here will be the opposite, and this down here will be the adjacent to the angle alpha, and tan equals opposite over adjacent, and hence we end up with this equation right here. Tan alpha equals opposite over adjacent, and you don't have to like swap these things, you know, it will work out itself because there are times where they will tell you what the length of the line of sight is. In that case, like they are giving you the hypotenuse, or they might ask you for the length of the line of sight. All right, so fact of the matter is that you end up with a right angle triangle, and you can do your normal so-called tower Pythagoras' theorem trigonometry in this right angle triangle. And they will give you information about the distances and so on. You just have to read carefully to ensure that the distance they explain to you in words is the distance that you represent on the diagram. All right, and I've seen cases where the distance that they describe in words, people are putting that distance at the wrong place on the diagram, and I'll give you some examples of that as we go. All right, so some things to note now, guys. As I said, the angle of elevation, alpha, is the angle between the horizontal and the line of sight when looking upwards. All right, so that's this one here. angle between the horizontal and the line of sight when looking upwards. All right, and we can say it's the angle through which the line of sight has to be elevated. So this line of sight had to be elevated. So the line of sight was here first. It had to be elevated through this angle in order to look up there. All right, so that's the angle of elevation. The angle of depression now is the angle between the horizontal and the line of sight when now looking downwards. So all that it is, elevation is looking upwards, depression is looking downwards. Concept is the same. All right. So angle of depression here is the angle between the line of sight, the horizontal and the line of sight, but this time you're looking downwards. In that case, is the angle through which you have to depress the line of sight in order to look downward. Now, one common mistake with the angle of depression, right, is both angles are measured from horizontal, and angle of elevation from the bottom equals the angle of depression from the top. So let me show you a little diagram right here now about angle of depression, a common mistake that people have. So let's say that's a vertical tower, and the angle of depression from, let's say the vertical tower, the top is T and the bottom down here is B. Down here is B, and there's a point P out here. And let's say the angle of depression, angle of depression, angle of depression. I'm showing a common mistake from now. Angle of depression from T, that's the top of the tower, to P is, let's say that angle is, let's say that angle is 30 degrees. I want to represent that 30 degrees on the diagram. All right. So it's like from up here, you want the angle of depression down to there. So to represent that on the diagram, you put in the line of sight. So the mistake is that a lot of persons put in the line of sight looking down. It's the line of sight looking down, but they put the 30 degrees here. Now that 30 degrees at that diagram is measured from the vertical, which is wrong. The angle of depression must be measured from the horizontal, not from the vertical. So this 30 degrees inside here will be wrong, guys. Let's not do it. Inside here will be wrong. So what you have to do, you have to put in a line for your horizontal up here. Let's put it on in black, for example. That would be horizontal. The angle of depression now would be the angle down here looking down. That would be a 30 degrees. Then now, because the angle of depression is 30 degrees, it means that the angle of elevation from down here looking up is also 30 degrees. And how is that one measured? That one is always easy. It's the angle from the horizontal now, looking up. So this is horizontal and you're looking up this way. All right, so that is it. So the angle of elevation from the other end will be the same, 30 degrees. And you'll be working in this triangle. You'll then be working in this triangle right here. And your trigonometry in this triangle, which is a right angle triangle. And if you know this distance and this height, and or you want to find this, you know something. And let's say you want to find a height and you know this distance. This distance is 20 meters. Then you're good to go. You can use so-called tower. In that case, you use tan equal opposite over adjacent and work out what your height is. That's a simple example. What I wanted to highlight to you guys is that the angle of depression is never right here. This is wrong to put an angle of depression there. So let us not make that mistake. It must be measured from the horizontal line. Must be measured from the horizontal line. Now, 90% of the time, the question will be about angle of elevation. Ever so often, they will set an angle, set a question with depression. All right, and maybe that's one of the reasons why people make mistakes with the angle of depression questions, because they don't set them very often. They tend to set the elevation questions a lot more. So let us remember this one. This is not the angle of depression. All right, it's not measured with the vertical, it's measured with the horizontal. All right, so let us not put any angle of depression there, please. All right, remember that one. And the most we need to do now is just do some questions. All right, I'm not going to do anything more. I don't want to be teaching anything that is more than simple. I really wanted us to maybe start some non-right angle triangle stuff today, but we will have to do this anyway. So let us make this one be the one for today. I wanted to do something else, but I think because of the small number of persons in attendance, this is easier to explain for persons who are not here. All right, so I'm gonna bring up and let us do some questions from the handout. I have it on the screen here. All right, so this is in the homework section of the handout. So let me bring up something else that we can work with, and bring up something else. All right, so we're going to practice a couple questions, so get a chance to apply what I've just explained. All right, you come back to class, and give you a couple to do. What I would want you to do is I'll do these examples for you, and because you have the video, you are to redo all these questions, redo the examples that I'm going to explain now. All right, they're very easy. Redo them to get the practice. All right, so when you come back to class on Wednesday and Thursday, we can basically move on to the next level of trigonometry, which is the non-right angle triangles application, which is bearings. So we'll be doing bearings in the next class. All right, so let us do some of the questions on here, and in particular I want to do some of the elevation questions. All right, so let's just jump straight into a nice one, which is right here. And this is what I like to set the elevation questions with multiple triangles in the diagram. So in this diagram, for example, there's more than one right angle triangle in there. So there's a right angle triangle here, and they kind of intertwine with each other in a sense, they're interlocking triangles. And then there's another right angle triangle up here. And you have to know which triangle you're working in. You have to decide which triangle you're working in for your calculation. They like to do this in questions, alright? So you have to identify that those are two right angle triangles, two separate right angle triangles. This triangle right here is there as well. It's not a right angle triangle, this one. And so if we're working in this triangle that I marked out, we cannot use so-called tower, and we cannot use Pythagoras' theorem. Remember, so-called tower and Pythagoras' theorem can only be used on right angled triangles. If we had to work in this blue triangle that I have on the screen here now, we would have to use the sine rule or the cosine rule for our calculations. Right? But usually, all these questions set up is that you have to work in the two right angle triangles. So you have to work in the small one to find something, and you also have to work in the large one to find something. And you have to realize now that this distance up here, this side, right, part of it is on a small triangle and all of it is on a large triangle. So this piece right here is the difference between those two heights, between this height and the small one and the overall height and the large one. And it's going to be that you need to find this height. That's how these questions usually are, this distance right here. So you subtract those two heights. But let's just do it. Enough talking. So this question says, let's read up here. This question says, the diagram below, not drawn to scale, shows a vertical tower FT. So this is a vertical tower right now, represents a vertical tower FT with a vertical antenna TW mounted on top. So that's an antenna on top of a tower. All right. And when you're doing these questions, guys, do not go abstract. What I mean by do not go abstract, think of it in real life terms. Just visualize this vertical tower and it has this antenna on top. When you're doing real life questions, the more you can visualize a real life situation, the easier it becomes. All right, so just think of a vertical tower, a tall building, a tall structure, and it has an antenna on top. All right, on top, and the antenna is vertical. All right, I'm going to give us some information now. It says a point on the ground, a point P on the same horizontal ground. So point P is on the same horizontal ground as F. So these 2 points are on the same horizontal ground. Now what we have here is a situation of we have vertical and we have horizontal meeting at F. The angle between vertical and horizontal must be 90 degrees. They're not going to tell you, you have to know. Angle between vertical and horizontal is 90 degrees. So it means that the angle right here is 90 degrees right here. And you represent a 90 degree with this like a square in the corner. Alright? So that's what we represent a 90 degree on these diagrams. You must know that by now. Because we have a vertical tower and a horizontal ground, I already know that I have a right angle there. And that's how we confirm that we're working on a right angle triangle, a small one, and a larger one. Both of them have the same right angle there in the corner. Alright? Then it says PF is 28 meters, and they show that on the diagram. PF is 28 meters. Sometimes they wouldn't show it and you have to put it on. And the angle of elevation, see here now, the angle of elevation of T and W from P. So let's read it again. Angle of elevation of T and W from P. So it's from P to W and from P to T. From P up to T and P up to W. T first, W next. What are those angles? 40 and 54. The angle of elevation up to T is 40 and up to W is 54, which makes sense because W is at a higher place than T. And the more you have to elevate your line of sight, the higher you have to like tilt your head back to look up is the higher the angle of elevation. Makes sense, right? So that is it. So you have to tilt your head more vertically upwards to look up at W as compared to looking up at T. So the angle of elevation of W must be higher from the same place. All right. So it means then we're gonna put these two angles on the diagram. Remember, both of them must be measured from the horizontal. Must be measured from the horizontal. All right. Angle of elevation, angle of depression are measured from the horizontal. So the lower one is the 40 degrees angle of elevation. So this is the horizontal eye level. I have to elevate the line of sight through this angle to look up here at T. So this is the angle that is 40 degrees. So let's put that on the diagram. So this angle inside here is 40 degrees. Let me make the pen smaller, thinner. Looking up here is 40 degrees. Then angle of elevation from the horizontal still looking up to here now is 54 degrees. Right? So you have to show that. So let me put it on in blue again. I'll put that measure on the outside. So the angle of elevation from horizontal looking up here to this line that is looking up at W. That angle is 54 degrees. I'm going to write 54 degrees here. So the 54 degrees is for the big triangle and the 40 degrees is in the smaller triangle. So that's what we have in there. Two triangles. You have to be able to see the two triangles. Alright? Everybody can see the two triangles? The big one and the small one. So the small one has a 54 degrees angle, 40 degrees angle in it. This distance of 28. And the large one has a 54 degree angle in it. 54 degrees angle in it. This distance is still 28. Alright, so we can work on these two triangles now. Alright, so the question says, copy the diagram and label it clearly showing the distance of 28. Well, the distance of 28 was already here. They want us to show the angle of 40 degrees and 54 degrees. So we have them here, 40 degrees, 54 degrees. And they want us to show any right angle. So this is the right angle we have here. That is the right angle. All right, so I've shown all that information. And then all I want to do now is calculate the length of TW, antenna TW. So the distance that they want is this little short distance right here. And all that distance is the difference between the height of the tower and the overall height of the tower and antenna. So you're gonna get that difference. You're gonna work on the small triangle to get the height of the tower, and then you get the work on the large triangle to get the height of the tower and antenna combined. And then to get this distance that they want, you take the difference between those two heights, the overall height and the height of the tower. You subtract them and you get this height that you want. But I can appreciate that. Simple and straightforward. But good? But okay?
Yes, sir. Yes, sir.
So
Please,
good. So
sir,
this
could
height,
you repeat the part with the length of antenna TW again?
say that again. Could I repeat what?
The part where it says calculate the length of antenna TW again.
Yeah, man. So you're gonna use the big triangle to
Mhm.
get the overall height up here, so of everything. And then you're gonna use a small triangle to calculate the height of the tower alone. So this height up here is gonna be the overall height of everything minus the height of the tower. That's what the height of the TW is gonna be. And we can literally write it out. The TW, I'm gonna do it over here. Is gonna be the overall height, which is FW. FW is the overall height. FW minus the height of the tower, which is FT. FT. That's how we're gonna get the height of the antenna. So we need to work out FW, we need to work out FT, and subtract them. Alright? Alright, so let's go. To get FW, we're gonna work in this big right angle triangle first. Where the angle is 54 degrees. Alright, that's what we're gonna do. So we're gonna work in a big triangle where the angle is 54 degrees. So I'm just gonna do it this time. Make a sketch for you. We want to work out FW first. So I'm gonna work in a big triangle like this. Where the angle in here is 54 degrees. This is a right angle. Foot is F. At the top is W. Out here is P. And right here is 28 meters. So that's this big triangle over here. Big overall triangle. Working on now. That's a right angle triangle. And so we can use so-called tower. What it is that we're trying to find this length over here now. This length. That's the opposite. And this length that we know is the adjacent. But it is so-called tower we use. And how you decide which of these three ratios we use is by the sides involved. Now the opposite and the adjacent are the sides involved. It's your opposite and adjacent. And you should know once hypotenuse is not involved, it must be tan. So I'm going to use tan tower to find the opposite, which is the height of TW. Right? So we're gonna say using tan, and don't start by putting TW, FW. We're gonna start by saying the tan of 54 degrees is equal to the opposite side, which is FW, over the adjacent side, which is 28. And then to make FW subject, you take the 28 and you multiply it across here. Cross multiply. We did this in class multiple times the other day. So the FW is going to be equal to 28 and the tan of 54 degrees. I don't have to work this out yet. I can hold it for the last. Remember, I said to you, you want to use a calculator one time at the end to get the answer. We know that this is the expression for FW. Now we need to work out FT. So to get FT, we're going to work on this smaller triangle now with the angle is 40 degrees. We're going to get a similar calculation. So now we're working on FT. I'm going to sketch that triangle again. This is now the smaller one. Angle here is 90, but here is still P. Sorry. Foot of the tower is F, and up here now is T, because we're now on the tower. Triangle with the tower. And this distance is still 28 meters. And the angle inside here now is a smaller angle of 40 degrees. Right there, looking up. So again, we're going to use opposite again, because we want the opposite and adjacent, meaning we're going to use tan again, opposite and adjacent. We want the opposite and we know the adjacent. Opposite and adjacent are the sides involved. But the angle this time is 40 degrees. So we're going to say the tan of 40 degrees is the opposite side, which is your FT. FT over the adjacent side, which is 28. And just like the first calculation, to make FT the subject, you take the 28 and multiply it up here. So FT is going to be 28 and the tan of 40 degrees. All right. So basically subtracting these two values, 28 tan 54 minus 28 tan 40. So we're doing this figure, which is this one, minus FT, which is this one. All right. So I can write it down here and say, okay, the TW height I want is equal to 28 tan 54 degrees minus 40 tan, not 40, 28 tan 40 minus 28, that's this one, 28 tan of 40 degrees. I put this in the calculator and I get the answer. TW equals, let's get a calculator, 28 so it's 28 tan 54 minus 28 tan of 40. I'm getting 15 meters, or 15.04 meters. Let's just call it 15 meters. I'm getting 15 meters as the height of the antenna right now, and that's the answer. But I did that. Any questions on that one?
No, sir.
No, very good. Very good. All right. So I'm gonna do another question that shows that TXT basically like to set almost the same thing. So let's do this one now, and then we're gonna do some questions, some parallel lines in it, like here and so on, right? And like this one, I want to do some questions with some parallel lines. We can pick up some Z angles and so on. I want to practice what we're covering today. But let's do this example. I'm going to say a similar thing with this question. This is another one here that we can maybe look at. I think I want to see one or two for the class. Let me see. But this one is one we do. We can maybe do that one, but I really wanted to like do this one. This one is kind of nice when we have the majority of the students present. Just wanted us to keep to the simpler things today, and then we can maybe do this one in a classroom. All right, but there's a little bit more in that one to explain. Right, so just keep to the simpler ones today, because so many persons not here. All right, so I'm gonna do this question. It's a very similar question, the one that we just did. So again, we have in the figure above, not drawn to scale, TF is perpendicular. So they don't talk about elevation or anything like that, but you know, we still have right angle triangle. So TF is perpendicular to FY. So TF is perpendicular to FY. That's why this angle is 90 degrees, right? To the square in the corner, that angle is 90 degrees. In this diagram, I see two right angle triangles. One here, that's one, and the other one is this. So if you ignore this, you have that big right angle triangle marked out in red. Alright? Alright, that's what they want us to do. So they give us some distance. They say fx is 40, that's right here. It says xy is 20, that's right here. It says, oh, we did this question in class the other day. We did this question the other day. We're asked to find xty up here. We did this question in class. Sorry about it. We did this question already. We did this question already. We did this one already. So I think this is one I need to do. Yeah, this is homework one still with this one already. That's still homework number one. Yeah, we did that one already. So this is one I want us to do. Sorry about that. Sorry about that. We did that question already. First question in homework 2. Let's go. Alright, let's see what this one says. It says the diagram not drawn to scale. You cannot look at anything and use any rule or anything like that on this diagram. It's not drawn to scale, guys, and you cannot go by how anything looks. It says G8 is a vertical pole. So this is a vertical pole and it's standing on horizontal plane. See, vertical and horizontal meet at 90 degrees. So right here is 90 degrees. So can you tell, let's put that in from now. Right here is 90 degrees. That's a right angle triangle. And that's another right angle triangle out here. Two of them. Alright. What does it says? It says the horizontal plane is HJK. And it says GH is 12 meters. That's here, the height of that tower. Of the pole, sorry. It's 12 meters. And the angle of elevation of the top, G, from J and K are 32 and 27 respectively. So from here looking up is 32 degrees, and from here looking up is 27 degrees. And you must expect that the one that is closer to the building is gonna, closer to the pole is gonna have a higher angle of elevation. The closer you are to a vertical object, is more you have to tilt your head to look up at the top of it. Just think of it that way. And so the closer you are to something that you're looking up at, is the higher the angle of elevation you will need to look up. Closer you are, all right? So it means then that the point J has a higher angle of elevation looking up than K, as compared to K. All right, so the 32 belongs to this, and the 27 belongs to that. That's what it is. And we can let's put them on the diagram now. Angle of elevation looking up here is 32 degrees to look up here. Over this end is 27 degrees. Try that better. Alright. It says copy the diagram and insert angles of elevation, which we have done, 32 and 27. The calculation time. Calculate one decimal place the length HG. That's this length right here. So to calculate that length, no problem. We're gonna come and we're gonna work in this triangle. We know two things. Well, we know this angle and we know this height. I mean, by any two things you know, apart from the 90 degrees, in a right angle triangle, you are blessed because you can find everything else using so-called tower and or Pythagoras theorem. Alright? So we can find anything that we want in that triangle right now. What do we want? We want this side. This side is adjacent. So we know the opposite and we want the adjacent. Again, the hypotenuse is not involved, so it must be tan. Tan does not include the hypotenuse. We're going to say in part 2 that the tan of the 32 degrees in this triangle right here is equal to the opposite side of 12 over the adjacent side of HG. Then to make HG short, we can multiply the HG to the tan 32 and divide it under. We saw those transposition in class as well. So the HG becomes 12 divided by the tan of 32 degrees. Alright, that is HG. And we can put that in a calculator and work it out. 12 over the tan of 32 is a fraction. 12 over tan. That's 19.2. 19.2. That's 19.2 meters. So I'm going to put 19.2 on the diagram here. And that's just this distance. Then now the next part now says let's calculate the length of JK, which is this little short piece right here. Let's look at it. They want us now to find us this length, J to K. And there are multiple ways to do it. That's the nature of trigonometry. There are always multiple ways to do a question. A lot of the times, multiple ways to do a question in trigonometry. So I want to find that like a red piece right there. Now, how I propose you find? Anybody want to tell me how I could find that like a red piece right there? We now know this length right here. We know this height. Remember that's a big right angle triangle out here. We know the angle in that triangle, we know the opposite side in that triangle. So somebody wants to tell me how can I calculate this length? Let me hear. What would you do? Anybody? Nobody wants to tell me how to find that length. Alright, so just learn it. Let me tell you. It's easy, you know. I don't know why you don't see it. To find that length, we're gonna work on this big purple triangle. The angle is 27, opposite side is 12. We're gonna find the full length across here, so this is adjacent. And then subtract the 19.2, that is all. Find the full length, HK, and then subtract the 19.2. That's all we have to do. Alright? That's all we have to do. Find the full length across here, HK, and subtract the 19.2. How do you find the full length across here? We work on the big triangle. Right? So that is it. So over here, let's do it over here. So for part D, we'll draw the triangle for you. We're going to be working on the big triangle. Where here is H, here is K, here is G. This is 12 meters high. Angle is 90 degrees. And the angle out here is, what is it again? 27. 27. It's 27 degrees. Alright, and remember you have G right here. So I can put on that for you. So G is right here, for example. That's G. And this length is 19.2 meters. This distance. We're going to work on a big triangle and find HK. Alright, so it's going to be tan because it is opposite. And we want the full adjacent. It's tan. So I'm going to say the tan of 27 degrees equals the opposite side of 12 over the adjacent HK. make HK, so we're going to take the HK, multiply it up here, 10 of 27, divide it under here. Easy transposition. So HK becomes 12 over the tan of 27 degrees. Put that in the calculator. Let's see what it is. Let's do it. Do it again. H over tan of 27. So a similar calculation here. Just add into the 32 and change 27. And we get 23.5. But it's a one decimal place. So we're going to put 23.6. Kilometers. Is kilometers or meters? Is it meters, right? Meters. So that is the overall length HK. So the small little piece that you want right here now becomes 23.6 minus 19.2. Right, so that is it. The GK, which is what you want, becomes the HK, which is 23.6 minus this one, 19.2. Very good at that. Very okay.
Yes, sir.
Alright, so that works out to be 4.4 meter. I said that better. This becomes 4.4 meters. That's that little distance there. All right. So we do some other questions. We'll get back to that, but I want us to touch on a couple of questions with the parallel lines now. So like this one, for example. See what part B is over here. All right, this one. All right. So for this one, I'm going to be doing this one over here. Question says the figure SJKM not drawn to scale is a trapezium with SJ parallel to MK. So these two sides are parallel, this one and this one parallel. What are the lines joining them? What are the lines joining them? They are joined by this line. So let me zoom in and show you some stuff right now before we start. So these two parallel lines, we want to find the lines joining them. So these two parallel lines, let's mark all the lines joining them, right? They are crossed by this line first. And so the angle in here and the angle in here add up to 180 degrees. They are co-interior angles. So since this one over here says 136, then we say that one here is 180 degrees minus 136 degrees. The two of them must add up to 1 here. Alright, let's look at another line joining those two blue parallel lines. They are joined by this line, this red line. And we can see the Z along this one, down the transversal line along this one. So this angle and this angle, they are Z angles, are co-interior angles, so they are equal. Alright, let's continue. Line joining those two is this one out here. Joining the two parallel lines just the same. So this angle, all of this, which is not 24, you know, because 24 is just right here. All of that angle and all this angle right here are up to 180 degrees. Alright, so those are some things that we identify. We don't even start with the question yet. Alright, we don't start with the question. Remember, you form these angles when you have parallel lines. Alright, so let's go. Let's answer the question. The question says the figure SJ is not drawn to scale. It's a trapezium. SJ is parallel to MK. Angle MJK is 24 degrees. That's the angle right inside here. It's 24 degrees. Angle MSG. Come on. Angle MSG is this one up here, 36 degrees. And then it says SM equals SG equals 50 meters. So this side and this side equal. And so we have an isosceles triangle. Right? In an isosceles triangle, the two angles opposite the parallel side, the sides that are equal. Angle over here and angle over here must be equal. This angle and this angle equal in that isosceles triangle. That's two equal sides and two equal opposite angles. So the angles opposite the sides are equal. In this diagram, it will be these two. And remember, total angle in the triangle is 180. So in this triangle, total angle is 180. These two equal. So to find these two is 180 degrees minus this 136 degrees. And you divide that by 2 to get what these angles are. Alright, so I'm gonna kind of go ahead of myself, but that's alright. So I must calculate angle SGM. SGM inside here. That angle and this angle is the same. So it's going to be 180 minus 136 divided by 2. So angle SGM equals 180 degrees minus 136 degrees. That's the sum of the two angles remaining. And then divide that by 2. That's how we get that angle. SGM. But understand that? Very good at that?
Yes, sir.
Alright.
Yes, sir.
That's 22 degrees. Alright, so let's put on a diagram. And as you find something, put on a diagram, guys. This can help you going forward. So this angle up here is 22 degrees. This angle is 22 degrees as well. Because they are angles in this isosceles triangle. Alright, which that angle they want us to find? They want us to find angle JKM. JKM. There's this angle on here they want next. Alright, that angle on here they want, which is kind of easy. Because, why is that easy? Because remember now that this line and this line parallel. Both of them are joined by this transversal line. And so that angle that they want down here, which is in red, and the whole of this angle up here are up to 180 degrees. That's how we can find this one that we want. Because 180 minus the sum of these two. Because this angle up here, across here, is the sum of 22 and 122. So part B, angle that I want, which is JKM, becomes 180 degrees minus the sum of these two, which is sum of those two is 146, right? 146. But understand the calculation? The co-interior angles are up to 180 degrees. But understand the calculation? Anybody don't understand? Alright. Nobody answering.
Yes, sir.
Alright. So we use the co-interior angles, alright, to get it. Next part now wants us to calculate some distances apparently. Let's see. Put it down as a find it. This angle only is 12 degrees. Alright. Only says calculate expressing your answer correct to one decimal place, a length of mg. mg. This line across here. Let's look at the diagram. Close up. Now we're gonna have to work in this triangle. we're gonna have to work in this triangle right here. Why? Because the triangle will have some distances on. I want to find this length across here. Well, that triangle is not a right angle triangle. Yes, it isosceles and can be divided into two right angle triangles, but it's not a right angle triangle. So you have to use sine rule and cosine rule. And then now, to use the sine rule, remember you need an angle and a side opposite each other, where you know both of them. So this angle, for example, is opposite to this side. And we know that both of them. And so we can use sine rule. And so we're going to use this pair that we have across each other with this pair in the sine rule. And it will work out itself. So we're going to use sine rule for mg. Let's go down here. So it's going to be, start with what you want. mg you want, start with what you want. So it's going to be mg over sine of the angle opposite to mg. Over sine angle opposite to mg is 136 degrees. Equal the side that you know, for example, the 50 over the sine of angle opposite to it, 22. This as a subject, you take the sine of 136 and multiply it up here. And you're going to put it behind the number. You multiply in a trig and a value, a numeral value like that. You put the trig after the value. You put it at the back. It means that the mg comes equal to 50 times the sine of 136 degrees divided by the sine of 22 degrees. I'm going to put that in the calculator. Alright, let's see. A fraction 50 over the sine of 22. It is times the sine of 50. I get 101. Now what they say, I'm going to do the small piece I said. It's a 1 decimal place, right? It's 101.2. So this distance is 101.2 running rate into
102.2.
102.2, yeah, 102.2 times 102.2 meters. All right, that's what we have, 102.2 meters. And that's it. mg is 102.2 meters. All right, and then they want us to calculate jk next. Where is jk? Where is jk? jk is this side over here, you know. So finish with this triangle. Let me take it off. We're gonna come and work on this triangle now. And again, we can use sine rule. Why? Why can't we sine rule? Because we have this pair of angle and side opposite each other. We know both of them. But remember now, we're trying to find this side. To find this side, so we're going to use this pair. You need to find the angle opposite to this side. We need to find the angle in here. What is that angle in here equal to? Let's look at it. So this parallel line, we have this parallel line, and they are joined by this transversal line. So up here, don't transversal and continue with the same direction gives you alternate angles. So since this angle is 22, then this angle here is also 22. That's alternate angles. So we can use this 22 degrees with this side now, and use this 102 with this angle right now. So you want to find a side, start with the side, put the side on top. Alright, so we're gonna put jk over sine of the angle opposite the jk. Angle opposite jk is at 22 degrees equal the side that you know, which is a 102.2 over side opposite to that, angle opposite to that, which is 24 degrees. And then make this is subject, make JK the subject. Get the sine of 22 and multiply it up here. I'm going to put it behind the numbers. Alright, the multiplier. So we end up getting that JK becomes 102.2 times the sine of 22 degrees divided by the sine of 34 degrees. Alright, so it's 162.2 sine of 22 over sine 34. Fraction 162.2 sine of 22 over sine of 34. I'm gonna get something is wrong. Oh, it's not. I have 116.22. Where you get that from? 162.2. Okay. All right. Good. It says 108.7. It's 108.7. And that is it. That is it, guys. I'm gonna do another one. Let's do this one. So I have some parallel lines on it as well. Let's do that one. I don't have to do too many things today. I don't like a lot of people missing from class. So the camera is good. Just gonna do this one and just do no measurement calculation. So I think I'm just gonna do this one. I'll call it a day. Because so many persons missing. I don't want to be doing too many stuff. I will pick it up back on Wednesday and Thursday. Alright. Let's see if there's anything in. These questions down here are for when I cover bearings, which I'm gonna do Thursday and Friday. Alright, let's just do this one. So let's put it on the screen. Let's see. This one says in the diagram shown below, ABCDE is a pentagon. Alright. BAE is 108 degrees, which is right here. ABC is 90 degrees right here. AED is 80 degrees over here. I think this question requires something I would do. Let's see. And this angle inside is 57 degrees right here, right? And then these two lines parallel. So these two lines parallel. So since those two lines parallel, let's pick up on some stuff now. First thing, they are joined by this line across here. And so these two angles are equal. They are alternate angles. So this angle over here is 57 degrees as well. Okay, let's put that in now. But the whole thing across here is 108. And this piece is 57. And this piece must be 51 from here to here. Alright. I want us to find angle X. So X kind of easy, you know. I'm sure your X easy. Your X easy. I kind of did something that we did not need to do. But we have this side. And we have this side. They are parallel. And they are connected at the head with the straight line. And so this angle and this angle, they add up to 180 degrees. Well, them add up to 180 degrees. Then since this angle over here is already 80, it means that angle over here must be 100. So you can say x plus 57 degrees equals 100 degrees. So x degrees is 100 minus 57. X degrees is, what is that? 43 degrees. So the value of x is 43. As if x degrees, 43 degrees. So the x itself must be 43 itself. That's it. Alright, so x is 43. You know what? The y angle now. Alright, let's look back at the diagram. Put in what we have. And look back at the diagram. Put in what we have. And we just worked out that this angle on here is 43. This angle what? I think to find that angle, you see, we're gonna have to come and work in this quadrilateral. This quadrilateral right here. Total angle in a quadrilateral is 360. One of our topic will cover those things, but I was telling you now. Total angle in that red quadrilateral is 360 degrees. So if we know these three, add them up and subtract from 360, we get this one. This one kind of straightforward. So the y will be 360 minus the 90 minus the 51 minus the 57. Whatever the zero code is a value for y. But after that, and notice I didn't put on the degree on it. I didn't put on the degree on it, guys, because I don't want y degrees, same thing. I don't want x degrees. X degrees is right here. This should be x degrees, 43 degrees. And I don't want y degrees, so I put on the degree on all of them. And write that out. Within 162 degrees. Yeah. But after that,
Yes.
I'm gonna call it a day.
Yes, sir.
So you can do for me, guys. When I send the video, go back over it. I mean, you haven't done much elevation question. I just did a simple one for you. I want to save this one, like this one for, you know, when we're in the class with everybody and so on. And then when we revise on Saturday online, then we revise some past papers and do some really nice questions. Right. Time is it now? Can do one more. I save for the next class because too many persons not there. I don't want to be doing everything. So many persons not here. So I'm gonna call it a day, guys. Don't be like do 2 minutes stuff. You know, when so many persons absent. Even though recording. Yeah. Not a lot of persons here at all. Alright guys, so that is it. And if I was in the class today, I know that more persons than in this call now would be in the classroom. So let me call it a day. Now we pick it up back on Thursday and Friday. I'm gonna share this video so that the person who are not here maybe get a chance they can watch it still. But we'll pick up on Thursday, Wednesday and Thursday. Alright, but alright guys, see you then. Bye everybody.